All right, so today we're looking at tree diagrams. Now, starting the tree diagram is probably the hardest bit that you will have to tackle, but once you can see how it works, you'll find it pretty easy. It's just about understanding what the question's asking you. So that's why I thought today, I've got a couple of questions here which have a tree diagrams already made out for you, so it might make it a bit easier for you. So with the tree diagram, okay, it's showing us our sample space involving two or more components, okay. We produce each step with branches, okay, and we talk about with replacement and without replacement, and I'll talk a little bit more about that as we go through. Okay, looking at this very first question, as you can see, we're talking about a coin that's being tossed 3 times. This is quite a common question that we like to put in. And if you know, with a coin, there's only a chance of you getting a head or a tail. So what happens is the outcome is what happens after I've tossed the coin 3 times. So each of these sections, that's for your first toss, that's for your second toss, and then that's obviously for your third toss. So these diagrams can get quite big depending on how many elements we're going to throw at you with regards to, let's say, how many times we would toss the coin. So in a test situation, you would list the outcome, you would list these 3 tosses with the branches, and it's also important to list the probability. Now what you're noticing here is that there's half a chance in the first toss of getting a head or a tail. There's half a chance in the second toss of getting a head or a tail, and there's half a chance of getting a head or a tail in the third toss. So my chances of getting head, head, head is a half times a half times a half, which equals 1/8. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8. All right. So this is how we then end up working out our probability. So once you've actually got the diagram set up, typically worth 3 or 4 marks depending on the type of tree diagram we're going to get you to get. Then we would ask you to find out the probability of me getting a head, head, head. So the probability of getting a head in 3 tosses is 1/8. So then answering the questions afterwards is actually fairly straightforward. That part probably will not be the most difficult part for you. So it's about getting this part correct. Now, if we go through to question number 2, now what you can see here is we can actually make the diagram a little bit smaller by looking at what the question is asked and stipulated to us. We can use those fractions a little bit better. So we're awarding 2 prizes, all right, to 3 males and 5 females. They've asked us to copy and complete, but you can write this obviously in your notebook, and to finish off the missing outcomes. Okay, so in my first, because there's 2 prizes, so this is going to be the first prize, and this is going to be your second prize. So when we look at this scenario here, what we can see is it's a 3 out of chance of being a male, because there are 3 males, and then we've got 3 plus 5, which gets us the total of 8. Between all the candidates, there's 8 candidates, okay, in total. So there's 8 candidates in total. So for second prize, it's also 3 out of 8, okay, because this one is with replacement. So if the person wins the first prize, they go back in for the second prize. So therefore they have another chance of winning the second prize as well. Hence the 3/8. So it saves me having to write, because if I had to do this the longer way, I would have 1, 2, 3. I would have male for the first prize, and then 1, 2, 3, and then male for the second prize. Now, if I was to do this, especially when we get to females, because there's 5 females in the running here, those get really long. So I would have to do another 3 off there for the males, and then we'd start with the females, and there's 5 females. up for the running. So as you can see, my diagram's getting very tight and very messy. So you want to try and avoid this situation, hence why we now use the fractions to make it a little bit easier. Okay, so we've already said that there's 5 females, so this one in this box is going to be 5 over 8. So then my fraction is going to be 3 over 8 times 5 over 8. 3 times 5 is 15 over 64. Good. Right, so as discussed, there are 5 females. So this one's going to be 5 over 8 down here. And there's 3 males, so it's going to be 3 over 8 here. And then this is supposed to be a 5 over 8. That just seems to have cut out there. So we've got 5 over 8 there. So now my outcome is female male is a 5 over 8 chance times a 3 over 8 chance, which is 15 out of 64. Then we've got female, which is 5 over 8 times 5 over 8, which is 25 over 64. All right. So hopefully now you can see the benefit of using the fractions a little bit better in this scenario. Rather than having to draw such a big tree diagram like that, use the fraction method. It will make it so much easier. Now, as I mentioned before, I was going to talk about the option of what we call without replacement. Now that means if a male gets picked for the first prize, okay, so in this scenario, first prize, there's 3 males in total, so it's still 3 out of 8 for that one. But if he gets picked for the first prize, that means he's now out of the running. So if I was to do it the long way, first option we have here is 3 males for the first prize. But now because he won the first prize, he's out of the running for the second one. Okay, so now there's only 2 males left in the running, as well as 1 less person in total. So it's now 2 over 7. So that's where you just need to be a little bit careful. When you do it without replacement, you're removing a person from the chances of winning. So it's now 3 over 8 times 2 over 7. Now with the males, the male being the first prize, we still have 5 females. So it's still going to be a 5 at the top, but there's still only 7 people in the running because 1 male has been removed. So we've got male, female, 3 over 8 times 5 over 7. All right. Moving on to the females. All right. Now the females, we've got still first prize. There's 5 females. And if a female wins that first prize, that means now there's only 4 females left in the running for the second prize. So hence the 4 over 7. We then end up with female male. So 5 over 8 times 3 over 7. And then the last option is female, which is 5 over 8 times 4 over 7. So when you read a question, we will very much clearly stipulate if it's with replacement or without replacement. And then you will know which type of diagram you need to work with. Okay, so that's hopefully made it a little bit more clearer what we're going to be doing today with regards to our tree diagram. All right, so let's have a look at example 10. We're dealing with boxes A and B that contain 4 counters each. Box A contains 2 red, 2 green, and box B has 1 red and 3 green counters. These are chosen at random for a single counter, so they haven't used the word without replacement. So that means I can assume that they are going to be all replaced. All right. Now I know it's asking us for what's the probability of, so for A, what's the probability of me selecting a red counter from box A? So if I'm going to pick a red counter from box A, that means I've got 2 red counters in box A, and there's a total of 4 counters in that box, so it's 2 over 4. What's the probability of me picking a red counter from box B? So it's just box B. Well, there's only 1 red counter in box B out of a total of 4 counters, so it's a quarter. Fairly straightforward. Now I've been asked to represent this information in a tree diagram. They want us to list the outcomes and the probabilities, so very similar to what you saw above. So let's have a look at this. How am I actually going to start the diagram? Well, because we've got these 2 different elements, we're either picking from box A or box B. So step 1, allow enough space when you're drawing this as well so that you don't get too squishy. We've got to first pick from either box A or box B. So that's first option is your box. The second option becomes the counter, okay, which is the coloured counters. So in box A, we have an option of red or green. Then for box B, we've got an option of red or green. All right, so now let's work with our fractions. I'll do them in a different colour just to help us out with identifying it. So there's 2 options when I'm picking a box, either box A or box B. So therefore that's half a chance and half a chance for either one of those boxes. Then when I start looking back at my box A options, how many red counters do I have in there? Well, the red counters that I have available to me in there is I've got 2 red over 4, and then I've got green. I've got 2 green out of a total of 4. All right. What about for box B? All right, so I've got 1 red counter out of a possible 4, and then I've got 3 green counters out of a possible of 4. Now, just to make your life a little bit easier when you are doing your probabilities, if you don't simplify, that's okay. You still get the right answer. But just to make your life a little bit easier, it's not a bad idea to think about just simplifying these just to make it a little bit easier. All right. So then we're going to list our outcomes. So once we've got our box and counter, and that's our tree diagram, we now list our outcomes. And you can use abbreviations to help you so you're not wasting too much time writing the whole word out. So my outcome is box A and a red counter, box A and a green counter, box B and a red counter, box B and a green counter. So my probability is a half times a half, which gets me 1/4, a half times a half, which gets me 1/4, and those are my probabilities for my box A options. Then I move down to box B options, and I've got a half times a quarter, gets me 1/8, and then I've got a half, need to write properly, a half times 3/4, which gets me 3/8. Fabulous. Give yourself a tick, 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 tick. So that's 4 marks, minus 1 per error. Then we can move on to, so this was C. Now we can actually move on to what is the probability of selecting box B and it's a red counter. So box B and a red counter, probability of B and a red counter is 1/8. That's simple. So you're doing all the hard work when you do the tree diagram. Probability of selecting a red counter. Okay, so now we want to just select a red. Okay, so the probability of me selecting a red counter is it could be from the red, it could be from box A or it could be from box B. So the probability of box A red is 1/4 plus the probability of me getting a red counter from box B is 1/8. All right, now I'm stretching your memories. We're now doing adding of fractions. When you add fractions together, they have to be the same denominator. So I'm just going to times this 4 by 2, and what you do to the bottom, you do to the top. What you do to the bottom, you do to the top. So you end up with 2 over 8 plus 1 over 8. And that gets you 3 over 8. And that's your probability. That's probably one of the more harder questions I would throw into your exam. All right. Good. You're doing well. So make sure you've got this copied down into your notebook and make sure you've showed all the working out so that you know exactly where the answers are coming from. All right. This is my extension style question. The reason it's a bit more extension is we're talking about a bag that has 5 blue and 3 white marbles, and we're selecting 2 marbles, but it's without replacement. There's that wording I need you to be aware of. And then they've asked us to draw a tree diagram. They want the outcomes and the probabilities listed. So we're making 2 selections from our bag. We know that we've got blue and we know that we've got white options. Now this is the first selection. So my first choice. Nothing's been removed in this first selection. So we've got 5 over 8, because there's 5 blue marbles. 5 plus 3 gets me the 8. And for the white, now I've got 3 over 8 options. Okay. Now I'm moving on to selection number 2, where I still have blue and white marbles for selection 2. So for my second choice. However, I've now removed a blue marble in the first selection. So that means now there's only 4 blue marbles left. And I've removed one. So now it's 4 over 7. There have been no white marbles removed yet. So this is still 3, but it's also still over 7 because the blue one has been removed in the first choice. When I pick a white marble, there's still 5 blue, but there's only 7 marbles left in total. Because I picked a white, now there's only 2 white marbles left out of a possible 7. All right, hopefully you felt comfortable with that and you can see how I'm getting my numbers because I'm not putting the marble back in the bag. Okay, I've removed it. So we then list our outcomes and then we're listing our probabilities. Okay, my outcome, blue, 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 white, white, blue, white, white. So the probability is 5 over 8 times 4 over 7, which leaves me with 5 over 14, but they've simplified that, so it's 5. Let me just, so we've ended up 5 times 4 gets me 20 over 56, which simplifies to 5 over 14. We've got blue marble, white marble, 5 over 8 times 3 over 7 gets me 15 over 56. Then we've got white blue, 3 over 8 times 5 over 7 equals 15 over 56. And then my white option is 3 over 8 times 2 over 7, which gets me 6 over 56, which simplifies down to 3 over 28. It's up to you if you want to just keep it simplified or have the full one worked. As you can see, for blue, blue and white, white, the fractions could be simplified. Either way, you're going to be fine. Great. Find the probability. Oh, hold on. Give yourself a tick. 4 marks there. Brilliant. Now, find the probability that it's a blue marble and it has to then be followed by a white marble. So we want the BW option. So BI, the probability of me getting a blue-white combo. And you look across at that and it equals 15/56. Brilliant. Now, what's my chances or probability of getting 2 blue marbles? My probability of getting 2 blue marbles. Probability of getting 2 blue marbles is 20/56. over 56, or if you decided to use the simplified one, it's 5/14. Last one, exactly 1 blue marble, but it doesn't matter where the blue marble is. So as long as it's 1 blue marble, okay, so 1 blue, don't mind where it is. So this is where you get the adding part coming into it. So we've got 5/8 times 3/7 plus 3/8 times 5/7. Now if you look back up there, look where we've got a blue marble available to us. Okay, so I'll just highlight it. So 1 blue marble there, 1 blue marble there. That's where I'm getting my numbers from, as you can see. So that's leaving me with 15/56 plus 15/56. 15 plus 15 is 30/56. And this can be simplified down to 15/28. All right. Now I can see that for question C, for this question, they've asked us to repeat the experiment, but now do it with replacement. Okay, so that means now you're not taking a marble out. I'm more than happy, because the harder one is the without replacement part. If you would like to have a go at doing question C, and then in your textbook, have a look at the result for that on page 182 in your textbook. That will tell you what the result is for C, okay? Hopefully this makes a little bit more sense and you will be okay with completing the questions.